In this tutorial, we'll be discussing about the application of derivatives in the case of related rates. For instance, we'll be discussing about the cube and how this cube is getting expanded in terms of surface area, volume, and diagonal. You know very well about the that is a cube. It has got equal sides. Let us assume x as the side. So what is the total surface area? That is nothing but 6a squared, in this case 6x squared, is it not? Right. And the next, the volume a cube, which is nothing but that is x cube in this case. Okay. Then we have diagonal. So diagonal that connects the opposite edges, is it not? So that is cube root of x. So these are the basic formula, and we are going to work out with this formula. The very simple thing here is v is equal to x cube. Now, what is the differentiation? That is dv by dt, rate of change of volume. As I already mentioned, any change taking place, in this case, volume change with respect to the short interval of time, that is dt. So dv by dt. So we know already x cube means 3x squared of dx by dt. Okay, 3x squared of dx by dt. And what about surface area, the total surface area, that is 6x squared. So here we have 6x squared. So on differentiation, it gives ds by dt, is it not? So 6 into 2, 12, 12x into dx by dt. So this is another one. Okay. Then the third equation is regarding the that is root 2. I mean, it's diagonal. Okay. Now in this problem, it is asked that is if the x is the length of the edge of a variable cube, find x and dx by dt when the volume surface area are increasing at the rate of. So when I say increasing the surface area means dA by dt. Increasing cube volume means dV by dt. So you have to, and not only that, based on the unit also you can arrive at. So here it is given 50 centimeter cube. So 10 centimeter cube is the volume. So dV by dt. And here area. So dA by dt. Okay, respectively. So here surface area, volume. So this is volume dV by dt. So this one is dV by dt. And what about this? This is dA by dt. Okay, so we know already the formula, and based on that you can work out. You just substitute and see, that is we have worked out s is equal to 6x squared. So dV by dt, and we have ds by dt also. So by dividing dv by dt and ds by dt, we are able to get, you can cancel that dx by dt. That is the easiest way, so that we are able to get the value of x. And similarly, once you are able to get the x, then you can substitute here and get the value of dx by dt also, is it not? Now we have got the value of x here, and this can be substituted in this equation, that is equation number 2, where you have ds by dt, we have the value of ds by dt, then 12x, 12 into x is 20. Okay, and the dx by dt can also be found out, and which is nothing but what, that is 1 by 24. So just substituting you will get. Okay, right. So we have now x and dx by dt. Now let us move to the next one, cuboid. So previously we discussed about cube. Now we are going to discuss about cuboid. So in the case of cuboid, we have LBH of different dimensions, is it not? So different measurement. So the total surface area is 2 into LB plus BH plus LH. That is the formula. And what about this? V is equal to LBH. And what about the diagonal? The whole square root of L squared plus B squared plus H squared. So now let us get into the problem. If height, breadth, length of a variable cuboid are, so it is given x, 2x, 3x respectively. So L is taken as that is height. So height is taken as x, and B is 2x, and L is 3x. Okay. Now find the rate at which the surface area. So rate of surface area is asked. Similarly, rate of volume is asked. Similarly, diagonal are also asked. Okay. When x is equal to 10. Okay. Right. Now surface area. Let us work out the surface area where surface area is equal to, so 2 into LB plus BH plus LH, you can substitute all these values and you got that is 22x squared. So S is equal to 22x squared, and based on that now you can differentiate. So ds by dx, that is equal to 2 into 22, 44x. So 44x. Now this is the value, and what is asked here at x is equal to 10, what is the ds by dx? So you can put ds by dx at x is equal to 10 centimeters. So ds by dx at x is equal to 10 centimeters. So we have got 44x. So 44 into x means you can substitute this. So the value is 440 centimeter. Okay. Now, so similarly volume. So volume is equal to V is equal to LBH. Substitute LBH. So you are able to get 6x cube. So 3x is 3 into x, then x squared. So 18x squared. Now substitutes in the similar way. Similarly, diagonal of the variable cube. So d is equal to the whole square root of L squared plus B squared plus H squared. So substitute the value. So you are getting 14 root x. So 14 root x. So dd divided by dx, is it not? So when you differentiate and the x becomes 1, so you are able to get only root 14. Okay, so the root 14 is the answer. That's all. Then and let us move to the next concept based on sphere. So in the case of sphere, we know already that is in the case of sphere 4 by 3 pi r cube, is it not? So this is the r radius. Okay, so S is equal to, that is surface area of a sphere, that is given by 4 pi r squared, volume of sphere 4 by 3 pi r cube. Okay, now based on that we can work out what is the question asked here. Radius spherical balloon increasing at the rate of, so it is given at the rate of, okay, when it is being inflated. Okay, so find the rate at which the surface area volume are increasing when it's a radius is 25 centimeters. So what is given here, that is the dr by dt, that is 2 centimeter base. So you always look at the unit. So it is length. Length means radius. So a radius per centimeter, is it not? So change of radius means a dr by dt. So dr by dt is given, and similarly at r is equal to 25 centimeter. Now let us work out the surface area and volume. So ds by dt and dv by dt. S is equal to 4 pi r squared. So for which we can work out, that is a ds by dt is equal to 2 into 4 then pi r, is it not? So 8 pi r into dr by dt. Now you can substitute ds by dt is equal to 8 pi into etc. and finally get this one. Okay, so similarly we can get volume. So in the case of volume dv by dt, so 4 pi r squared, 4 pi r it comes here. So 4 pi r squared. So this 3 can be cancelled. So 4 pi r squared. This, then pi r squared into dr by dt. So substitute and get the answer. So these are all very simple sums. You just think that is you must adopt the standard style and same strategy for everything. Okay. The very important thing is how to identify the given and what is asked. So that's very important. Then cylinder, and you must be well versed with the formula also of the given area or volume or what you call the diagonal. Okay, right. Now let us consider cylinder. In the case of cylinder or H, so you know that is a total surface area, which is nothing but the curved surface area plus 2 circle area. So 2 pi r H plus 2 pi r square. So that is the formula for total surface area. And then V pi r squared H, that is a volume. Now let us proceed. If the radius and the height of a variable right circular cylinder are increasing at the rate of, so 2 centimeter per second, so which is nothing but radius and height. So one is radius, another is a height increasing. So 3 centimeters. So dr by dt is given, dh by dt is also given, 2 and 3 respectively. Okay. Now find at which total surface area volume increasing, height is 20 and 5. So height 20 and r. So in that case, what could be the increased volume? So we know already S is equal to 2 pi r h plus pi r squared. Just apply the differentiation formula. So you have 2 pi in, that is the constant. So you have now RH. So RH means a dH by dt. So when you differentiate, you are able to get R into dH by dt plus. And what about this? Simply R squared. And before that, you have got two variables, is it not? R and H. So you have to adopt UV formula. So you have to remember. So when you have two variables, what you are supposed to do? You have to adopt UV variable, UV formula here. So here 2 pi R H means R is one variable, another variable is H. So 2 pi being constant, you can take outside the bracket. Now what you are supposed to do, that is R into dH by dt. Okay, plus, and you have to keep the H constant and dr by dt. That's all. Okay, so remember this, when you have two variables associated like UV, then you have to adopt the UV formula. Never forget UV formula. Okay, so here we have applied. And then 2 pi r square, that's very simple. That is a 2 pi into constant r squared is nothing but 2r into dr by dt. Okay, now you just substitute the relevant equations. Okay, given values, then you are able to get ds by dt, and that is nothing but 150 pi centimeter squared per second. And remember the appropriate unit also. Okay, then always put per second for changes. Then V is equal to 4 pi r squared h. So in this case, pi into r squared into dh by dt, and plus the same UV formula. Okay, so you remember, apply the same thing. Now substitute, so we'll get this answer. Okay, so the very important aspect about this cylinder is you must remember that R and H, there are two variables associated. So you have to appropriately deal with that by using UV technique. Okay, right. And then cone. So cone is the another thing. We have got the right circular cone here. We have the circular base like this, and for which you have one other variable is R, another variable is the vertical height, that is H, the third variable is slant height. So all these things are very important. So here uh, V is equal to 1 by 3 pi r squared H. How many variables are involved? Two variables are involved. So you have to be very careful. Now 1 by 3 pi r squared H, that is 1 by pi r squared into R by 3, that is equal to 1 by 9 pi r cube. So now listen, it is given as R is equal to 3 times of H. So in that case you can substitute here. Okay, so instead of R you can, I mean H, you can put R is equal to 3H, means what about H? H is equal to R by 3. So you can convert this and make it as a single variable. Now you have made it as a single variable. Now what is the volume of the cone? Which is nothing but 1 by 9 pi r cube, in the case 3 times of height, when r is equal to 3 times the height. Okay, right. Then V is equal to 1 by 3 pi r squared h. In this case, um, 1 by 3 pi r squared h. So you have put 1 by 3 and pi. And here in terms of h we have worked out. So this is in terms of r and this is in terms of h. So remember both this formula, assuming that that is r is equal to 3h. Okay, right. Now, in both cases, you can work out that is the dV by dt, and that is equal to 1 by 3. So you can play around like this. Okay. And what about this? This is in terms of dH by dt. This is in terms of dr by dt. So you should remember both. So, so R is equal to 3. So based on this, we proceed. Okay. Right. Now, look at this sum. Falling sand forms conical heap on the ground in such a way that its radius is increasing. So falling sand means that is you are pouring some sand particles, so it forms a cone like this on the ground. So it will be growing like this, is it not? Okay, it will be growing like this when you pour the sand particle. So this is the idea. Now the radius of cone is formed is always 5 times of its side. So they are given the relationship as r is equal to 5h. So you must utilize this that is a ratio effectively. Okay, and find the rate at which rate of sand falling when the radius of the cone is 20 centimeter. Okay, so the rate, find the rate with which the sand is falling. Okay, the sand is falling, so which is nothing but the volume change, is it not? Now in a variable cone, the same thing, R is a given, so it is given 5 times, so 5 is equal, R is equal to 5H. So dr by dt, that is equal to 1 centimeter, that is also given because it is given at the rate of 1 centimeter increasing, radius increasing. So dr by dt is given, and R is also at the 20 centimeters. So you can find the dV by dt volume. So volume is equal to 4 by 3, 1 by 3 pi r squared h. So you can differentiate with respect to t. So dV by dt. So 2 comes here, is it not? And before that, you have to change accordingly because it is given as R is equal to 5H. So we have changed, we have substituted the H by R. So 5H is equal to R, means H is equal to R by 5. So that's why I put R by H. Now ultimately 1 by 15. See, the tactic here is they are trying to change it into single variable so that you can conveniently go. So now it is with the one variable only. Now we can that is differentiate. So dv by dt is equal to 1 by etc. So just to substitute, you will get this answer. Okay. Then uh, sixth one. Here, an inverted conical, see that is my dear students, I think I am rushing, but because we have got a lot of problems to be discussed, if you want that is a go slowly, you can pause and slowly go. Okay, so wherever you want to stop, you can stop, pause and play. So that is the best way, and simultaneously we have to take down the notes. Now, in an inverted conical vessel, so inverted conical vessel, okay, right, whose height is how much? 10 meter, 5 meter radius, filled with water, okay, at the rate of what? That is 8 cubic meter. So find the rate at which the water in the vessel rising in the depth, okay, of water. Now listen, see that is the inverted conical vessel. Though this is the vessel, it is inverted, so it's kept like this, probably in a suitable stand. Now whose height is 10 meter. So whose height is 10 meter. Okay. So the height is 10 meter. And then a radius. So base radius, here top radius. So radius is equal to 5 meter. Okay. Filled with water at the rate of 8. So it is filled with water. Okay. At the rate of 8 cubic meter per minute. So per minute 8 cubic meter. 8 cubic meter. 8 cubic meter per minute. So per minute it is given. Now find the rate at which the level of water in the vessel rising when the depth is. So it is now that is on pouring water, the level will be increasing here, is it not? So the rate of increase of this level is asked, which is nothing but what? That is dh by dt, is it not? The rate of level means height is increasing with respect to time. So they have asked dh by dt. Do you understand? Okay, so this is the logic. Now we'll come. So in a cone, it is given as what that is. It is given the ratio between height and the r. So h by r is equal to 10 by 5. So here this is 10, this is 5. So the ratio is 10 by 5, that is equal to 2. So h is equal to 2r. Is it not? Because h by r is equal to 2. So h is equal to 2r. So that's what given here. Now volume change is given 8 cubic at height 4 meters. So what is the volume? V is equal to 1 by 3 pi r squared h, and there is a relationship here for h. So you can substitute the value of h by 2r, is it not? Or r by 2h, either way, h by 2. So here h in place of r we have put that is h by 2. So h by 2 the whole square, that is h. So 1 by 12 pi h cube. So this is the converted equation. After that you have to proceed with the what? Differentiation. You should not go well in advance before converting. So we had to convert first as a single variable. Now the volume is in terms of height only. So we can conveniently that is differentiate. So dv by dt is equal to 1 by 4 pi h squared dh. Why? Because the 3 comes this height. So 1 by 4, is it not? And h squared, so h squared, so dh by dt here. So 8 cubic meters, so this is given, so this value is given here, and 1 by 4 pi into what is h is also 4 meter, you can substitute. Then here dh by dt, listen to me, dh by dt, so that is asked here. Okay, so dh by dt. So find out the dh by dt. Now forget about all these units, you can strike up all these units, it will be confusing. Okay, so we get what, that is 8 dh by dt is equal to 2 pi by. So are you able to understand this? So if it is confused with the unit, you can strike up, don't put this unit, that will be confusing. You can work out separately. You know very well h by t means what, that we are working on meter per minute only, so you need not put this one. Then so therefore 2 by pi meter per minute. Okay, are you able to understand this? Right, now let us move to the next sum. Water is dripping out at the rate of 1 cubic centimeter. So the same time, now it is a dripping out at the rate of 1 centimeter cube per second through the tiny hole at the vertex of the, now previous sum, that is we were pouring, now we are, that is uh, permitting the cone to leak through the bottom. Okay, now what happens here, there will be a drop in the level of what, the uh, volume of, I mean water. Okay, the height will be reducing. Not only that, even L will also be reducing, the lateral height will also be reducing. Now water is dripping through the, okay, vertical. Okay, so when the slant height, so slant height, which is nothing but L, is 4 centimeters. So L is equal to 4 centimeter, it is given. Find the rate of decrease. The rate of decrease of slant height means a dl by dt. So dl by dt is asked. The area of water surface. The area of the water surface means the top area. Okay. So the area of water surface, given that the vertical angle. So the vertical angle is 60 degree. So the vertical angle is 60 degree means the half of it will be 30 degree, is it not? Right. So the vertical angle here in this case 30 degree, when we put AC as the height, so 30, so ACB is 30 degree. Okay, right. Now let us proceed. So what are the thing we have to find out? We have to find out dl by dt, and then that is we have to find out in the next case the area alone, dA by dt. So there are two important questions. One is dl by dt, another is dA by dt. So this is represented by the surface, is it not? So dA by dt should be found out. Okay, so these are the two aspects. Let us proceed. dV by dt, that is these are all the given, we already noted, and you know very well that is a, since this one is the right angle, that is this is at right angle, A is right angle, so BAC, in that case when it is a 30 degree, okay, this is H, this is L. So based on that we can find out the other measurements also. So H by L means what? H is the that is the vertical height, is it not? And the lateral height is L, and this one is 30 degree, is it not? So R by L, what is R? This one is R, that is opposite side, and this is adjacent side. So opposite by hypotenuse is sine 30, is it not? So sine 30 means R by L. So R by L is given sine 30. So sine 30 means 1 by 2. Therefore R is equal to L by 2. So based on that, now we can give in terms of H also. So H by L is equal to what? That is cos 30. Is it not? So cos 30 we know root 3 by 2. So H is equal to root 3 L by 2. So we have R in terms of L and H in terms of L. So everything can be converted in terms of L only. Is it not? Now we have volume of water tank. So V is equal to 1 by 3 pi r squared H. Now we have the relation, two important relation 1 and 2. So here 1 by 3 pi r squared H. So in place of R you can put L. So L by 2 the whole squared, and into H, in terms of H means root 3 by L divided by 2. Okay, so work out all these things. Now you are able to get V is equal to 1 by 8 root 3 into pi into L cube. Now it is set as a single variable. So this is very, very important. So always set in your mind that you should convert RHS in terms of single variable so that it will be very comfortable while you differentiate. So L cube means 3L squared. So you put 3L squared and 3 root 3. So you can strike out. So finally you are able to get dl by dt. Just to substitute. Okay, so 48 by 8 root 3 dl by dt. Find out dl by dt from this relation. Okay, and similarly, so this is the what? Dl by dt, that is a rate of decrease of what? The lateral height. Okay, slant height. Then what about area? So area is equal to pi r squared. So why I have taken pi r squared? Because the surface area it is asked, which is nothing but the circular surface area. So A is equal to pi r squared. So R we know already, R by 2. So L square, L by 2. So L squared by 4. So dA by dt is given on differentiation. We are able to get this and by substituting the values. Okay, right. So, what are the important that is shapes? So far we have discussed. We started with the cube, and then rectangular cube, then cylinder, and then that is cone, then sphere, okay, and cone in terms of various aspects like inverted cone where we pour the volume inside the cone, and in the last sum we discuss about the water dropping out from the cone. So these are all the different strategies in this kind of problems. Okay, I hope that is you are able to understand everything. If you don't, if you have got any doubt, you can ask me during the live session. Okay, so you should be ready with the what I call the assignment subsequently followed by this lecture. Okay.